Hello, grade 8 students. Mr. Yoon here. I just wanted to put an answer key together for one of the geometry homeworks on quadrilaterals. So I'm just going to work right through the problems and provide the explanations on how to get the answers. Okay, so looking at question number one here, um, anytime you have an object with four sides, so I'm just highlighting the four sides there, that means we're dealing with quadrilaterals. And we know that quadrilaterals, the angles inside will always sum to 360 degrees. So let's use this fact while we're trying to solve the questions in this worksheet here. Okay, so with question number one, we need to find angle number one. So that's this angle right here. And you'll notice that the 105 is actually vertically opposite to angle number one. So angle number one is going to be 105 degrees because vertically opposite angles are equal. Okay, so if angle 1 is 105 degrees, and this box right here is 90 degrees because it's perpendicular, then we can find angle 2 because angles in a quadrilateral add up to 360 degrees. So if you take 360 degrees, subtract that 90, subtract the 120, and if you subtract the 105, which is this angle right there, then you'll get a grand total of 45 degrees. Okay, so angle number 2 has to be 45 degrees because angles in a quadrilateral add up to 180 degrees. Now I'm just going to erase all this, and what I'm going to do next is I'm just going to pause the video and write in the explanations. Okay, and here are the explanations. For angle number 1, vertically opposite angles are equal, and for angle number 2, that's going to be 45 degrees because angles add up to 360 degrees in a quadrilateral. Now, moving forward in this assignment here, whenever we see the word angle, I'm just going to replace that with this symbol right here. So instead of me writing out the whole word angle, I will just denote that with this symbol right here. Okay, let's move on to question number 2. Now, for question number 2, you should notice that the opposite ends, BE and RA, they're parallel, but clearly the side lengths in blue, they're not equal. So this is going to be a trapezoid. Okay, and when we're dealing with a trapezoid does have a few interesting properties. One interesting property that you should know is that when you have these parallel lines, then certain shapes will actually form, and one shape that does form is this letter C right here. Okay, so when you have a letter C there, when the opposite ends are parallel, we know that these two angles, angle 3 and angle 80, those two angles must add up to 180 degrees. So if this is 80, so if angle R is 80 degrees, then angle 3 must be 100 degrees because those two angles must add up to 180 degrees. So this will be 180 degrees, and I'll just kind of abbreviate this saying that the C shape, I'll say C shape rule, I'll say angles equal to 180 degrees, or they add up to 180 degrees. Okay, so we know this is a trapezoid because notice that another way to identify that we have a trapezoid here is because if you look at the opposite angles here, notice that they're not equal. So if the opposite angles are not equal, then we know we're dealing with a trapezoid. Okay, once again, if we're dealing with a trapezoid here, notice that we have another C shape over here, a backward C. So I know that this angle right here, 115 degrees, and angle number 4, that must add up to, those two angles must add up to 180 degrees. So angle 4 must be 65 degrees because 65 plus 115 is 180 degrees. And this is once again the C shape rule. Angles sum to 180 degrees. Okay, so same rules there. All right, let's move on to question number 3 now. Okay, so for question number 3, I noticed that the opposite ends, PO and YN, they're parallel. And I also noticed that ON in blue and PY over here, they're also parallel. So whenever you have these parallel lines, that means we have, and they're not equal. So notice that the yellow lines are equal, but the blue lines are not equal to the yellow lines. So if that's the case, and if all sides are parallel, then we know that we have a parallelogram. Okay, all right. So let's start solving all the problems now. What's PY? Well, PY is essentially the side right here, and it's saying that PY is equal to what? Well, PY is equal to its opposite end, which is ON. So this has to be equal to ON, and we'll just say that opposite sides are equal. Okay. All right, now what about angle number 5? Okay, let me just delete this. Here's angle number 5. So we're working on this question right here, angle number 5. Well, since we're dealing with a parallelogram, we know that the opposite angles in a parallelogram, they have to be equal. So angle number 5 has to be 120 degrees. And we'll say that opposite angles are equal in a parallelogram. Okay. All right, so let me just delete that. And the next question is, what is angle PYN? PYN, well, here's P, here's Y, and here is angle number N. Okay, so PYN. So the question is, what is this angle equal to? That whole angle right there. Well, for my previous problem, I know angle number 5 is going to be 120 degrees, right? I know those opposite angles are equal. And I know that in a parallelogram, I know that these blue angles, those blue angles right there, they need to add to 180 degrees. So if I know that this is 120 degrees, then this whole angle has to be 60 degrees, right? Because 120 plus 60 degrees adds up to 180 degrees. And once again, this is basically the C-shaped rule right there, right? So the C-shaped rule tells us that the corner angles there must add up to 180 degrees. So angle PYN, which is this entire part in red right here, that's going to be 60 degrees, and I'll just say the C-shaped rule. C-shaped rule, angles add to 180 degrees. All right, and there's other ways to get angle PYN, but I feel like this this reasoning is one way where you can quickly get the answer. Okay, moving on here. Next question is, what is angle 6? Well, angle 6 is right here, and angle 6 is going to be 20 degrees because we can just use the Z-shape rule right there. So there's my Z, and the Z-shape rule pretty much tells us that these two angles have to be equal. So this is the Z-shape rule. Okay, and finally, the last question is, what is angle number 7? Okay, so what is this angle right here? Okay, so one way you could solve this problem is that, once again, using the C-shape rule, I know that these two angles, 120 degrees and this entire angle, they must add up to 180 degrees. Well, since I have 120, I have another 20 there. That's going to be 40 degrees, 140 degrees total. So that means angle 7 should be about 40 degrees. All right. So I know this entire angle right here has to add up to 60 degrees because that was one of the previous problems, right? So if the whole angle has to add if the whole angle has to add up to 60 degrees, then we know that angle 7 has to be 40 degrees because 40 plus 20 equals to 60. And if this is 60 and that's 120, then both those angles add up to 180 degrees. Okay, so for angle number 7, we know that's going to be 40 degrees, and we can say that the C-shaped rule, or we could also say that angle we know that angle PYN, we know that equals to 60 degrees, so that means that this implies that angle 7 has to be 40 degrees because 40 plus 20 is 60 degrees. Okay, so sorry, I kind of went through that question a little bit quickly, but those are some of the rules for a parallelogram. All right, let's move on to question number 4 now. All right, so moving on to question number 4 here. For question number 4, we're given some pieces of information here, such as Cn equals to 2.7 centimeters. So this part right here in yellow, that's going to be 2.7. And we also know that WR is going to be 16.16. So this whole length right there, that diagonal is going to be 16.16. So let me just put this in red here, 16.16. And we know that CWO is going to be 75 degrees, and CWO is right here. This whole angle will be 75 degrees. Okay. All right, so first question is, what is the value of ON? So ON is this entire length right here. Okay, so let me delete all this. Okay, I know that Cn from here to here is 2.7, so that means O to N has to be 2.7. And if I add these two, since those two sides are equal in length, because that's one of the rules of a parallelogram, we know that ON has to be 2.7. And one of the explanation for this is you can say that diagonals of a parallelogram diagonals of a parallelogram, they pretty much they bisect each other, and bisect means that it cuts the length into equal halves. Okay, so there's a little reasoning right there for that question. Okay, let's move on to a WN. Now WN right here, that's this length right here. Now we know that this entire length WR is going to be 16. We know that WR is going to be 16.16. So WN, which is simply half of that, we just take 16.16 and we divide that by 2, and we get 3.08. So this is going to be 3.08 centimeters. And once again, we can just say that diagonals bisect each other, so this is half of 16.16. All right, great. Now let's move on to question the next angle here, angle CRO. Well, CRO is right here, CRO. Okay, so that's this entire angle right here. Now I know that CWO, which is over here, I know this is going to be 75 degrees. All right, so since we're dealing with a parallelogram, we know that opposite angles are equal. So this has to be 75 degrees, and the reasoning is that opposite angles are equal. Okay. Let's move on to now WOR. So WOR is right there. Okay, so what's this angle right there? Well, I know that CRO, this angle right here, is going to be 75 degrees. And I know that this angle right here in green and this angle right there, those two angles must add up to 180 degrees. So this has to be 105 degrees, because 105 degrees plus 75 is 180 degrees. And I can just say the C-shape rule. So angles add to 180 degrees. So this rule has come up a few times already. All right, let's move on to the next set of questions here. Question number 5 now. All right, moving on to the next question here. I have, just one second, I have an interesting shape right here. It looks like since I have these corner 90-degree boxes there, that means GOT, the whole shape, is going to be a rectangle. A rectangle. Okay, so a rectangle has a different set of properties. Okay, so let's break through this problem right here. We know that AG, which is this length right here, AG equals to TO, right? So those two are definitely equal because diagonals are equal in a rectangle. Okay, so one of the properties in a rectangle is that all diagonals are equal. Okay, so that's that part right now. Now AG is equal to how many centimeters? So AG is this whole that length right there. What is the length of that yellow line? Well, I know that the base right here is going to be 12, and I know that this side length is going to be 5 centimeters. And because I have this 90-degree box right here, I can use the Pythagorean theorem in order to find GS. So in order to use the Pythagorean theorem, this is going to be 5 squared plus 12 squared equals to, I'll just say GA all squared. Okay, so hopefully you can see that this is a triangle right here, and we're trying to solve for the hypotenuse, which is GA. Well, this will be 25, and this will be 144 equals to GA squared. And 25 plus 144 is going to be 169 equals to GA squared. And if I take the square root of 169, just like in the homeworks, we know that GA has to be equal to 13. Okay, so GA or AG, that's the same thing. This is going to be 13 centimeters, and I can just say this is the Pythagoras theorem. Okay. Okay, so let me just delete all this. Lots of stuff going on over there. Okay, so I know that GS, this whole length, is going to be 13. Sorry, GA is going to be 13. So that means this length from G to S, that's going to be half of that. So this will be 6.5. So GS is going to be 13. Sorry, GS will be 6.5 because this is half of 13. Okay, because we know that in a rectangle, we know that the ends here, they bisect each other. So those two red lines must be equal. So if the whole length is 13, then each individual piece is worth 6.5. Okay, so using that rule right here, let me just delete all this. We know that this is equal to that, and we know that this is equal to that. And then the final question is that what is triangle GSO? Well, GSO, and the final question was OSA. What are those two triangles? And since we have two sides that are equal here, since these sides are equal, we have two isosceles triangles. So these are all isosceles triangles. Same thing down here. Okay. All right, so take a look at that example one more time if you're having problems with that one. Okay, let's move on to question number 6 here. Okay, so question number 6, this entire shape right here, notice that all the sides are equal, right? So this means that this side and this side and this side and this side, they're all equal, right? So if all sides are equal and you have 4 sides right there, this is actually a rhombus. Okay, so a rhombus is a shape where you have 4 sides and all 4 sides are equal, and the opposite ends are parallel. Okay, so if you have a rhombus, a very unique characteristic of a rhombus is that when the diagonals intersect, they always intersect at right angles, and this is in the notes. Okay, so what that means is when you intersect, and when you bisect right here in the middle, you will intersect at 90 degrees. This is a property of a rhombus. So angle DOT, or sorry, triangle DOT, it's asking what kind of triangle is DOT. Well, since here's triangle DOT right here, DOT, and notice that once again these sides are equal, so that means whenever you have two sides are equal, we know that we have an isosceles triangle. Okay, and that's because the two sides are equal. These two sides in green are equal. Okay, all right, that's problem number 1. What about DYA? Where is DYA? Here is D, Y, and A. Like I said, in a rhombus, the diagonals bisect at 90 degrees, so this is going to be 90 degrees. And we'll say that diagonals bisect at 90 degrees. Okay, so assuming 90 degrees right here. Okay, and then we got to look at triangle DYT. Where is DYT? Here's DYT. So what about that mini triangle right there? Well, since there's a 90-degree box right there, we know that DYT is a right triangle, right angle triangle. Okay. All right, next question, DTA. Okay, so where is DTA? Well, DTA is this angle right here. This is DTA, right? This is a DTA. Okay, now for DTA, what you need to recognize is that if I just delete this, we have to recognize that this triangle here in green right there, that whole triangle is an isosceles because this angle right here, and sorry, this side right here and this side here are equal. So we have a isosceles triangle. And an isosceles triangle states that the bottom angles here, this 40 degrees and that angle right here, these two angles have to be equal. So angle DTA is going to be 40 degrees. And I'll say isosceles triangle property. All right, in an isosceles triangle, the two bottom angles are always equal. Okay, so the next question is, what is angle TDA? Okay, so TDA, so this is TDA. What is this angle right here? Well, I know that this angle right here is going to be 40 degrees. So if this is 40 degrees and that's 40 degrees, and this angle right here must be 100 degrees because angles in a triangle add up to 100 degrees. So TDA is going to be 100 degrees. And one reason is that angles add to 180 degrees in a triangle. Sorry, in a triangle. Okay, and finally OTA. Final question is, let me just delete all this. Okay, so OTA. This angle here is going to be 40 degrees because this is simply going to be the Z-shaped rule, right? So we know rhombus, the opposite ends are parallel. So OTA, which is this angle right here, that has to be 40 degrees because of the Z-shaped rule. Okay, so this will be 40 degrees, and I'll say the Z-shape rule. All right, let's move on to the next set of questions here. I want to try to finish this as quickly as I can here. Okay, so view, let me just downplay and zoom out. Okay, here we go. Okay, so question number 7 here. For question number 7, we have opposite sides here. And we know that the opposite ends here in blue, we know they're not equal. So MOLE, this has to be a trapezoid. Okay. Opposite ends. So because the opposite ends here are parallel, the yellow lines are parallel, but the blue lines are not equal in length, we call that a trapezoid. Alright, so let's go ahead and try to find angle number 1 now. Angle number 1 is right here. And let me just delete all these colors now that we know this is a trapezoid. In order to find angle number 1, I recommend using the Z-shape rule. So here's my Z-shape rule. So I know that these angles have to be equal. Okay, so I know that this angle right here is 36 degrees. That angle is 36 degrees. This is going to be 90 degrees. So this angle right here has to be 180 degrees minus 90 minus 36, which is going to be 54 degrees. This angle right there is going to be 54 degrees because angles in a triangle add to 54 degrees. Therefore, angle number 1 has to be 54 degrees as well. So this is 54 degrees, and I'll say this is the Z-shape rule. All right, we can use the Z-shape rule because those are parallel lines. Okay, let me delete this. Okay, what about angle number 2 here? So angle number 2 is this angle right there, but one thing you need to notice is that this whole triangle right here in yellow, we notice that these sides are equal, so this is an isosceles triangle. So if this is 54 degrees, then angle 2 has to be 54 degrees as well. So this is going to be 54 degrees, and I'll say this is an isosceles triangle property. Okay, and then for angle number 3, I know this has to be 72 degrees because angles in a triangle sum to 180 degrees. Okay. All right, let's move on to the final question here. Okay, for question number G, we're given, for question number 8 here, we're given that FR is 10 centimeters. So this part right here is going to be 10 centimeters. Now, if this is 10 centimeters, then this length here is also going to be 10 centimeters, because we're symmetric, and this will also be 10 centimeters. And finally, this edge right here will also be 10 centimeters. Okay, so since all the outside edges are equal, we're dealing with a rhombus here. Okay, so this is a key characteristic of a rhombus, is that all the outside edges are equal in length. Okay, so FG has to be also 10 centimeters because these are 4 equal sides. 4 equal sides. Okay, so you can take your 10 centimeters and distribute that to all the other sides, and there you go. FG will have to be 10 centimeters as well because everything is symmetric. Okay, the next question is, what is NR? And in order to find NR, what you need to do is you need to apply the Pythagoras theorem. So I know that this length right here, FR, is going to be 10 centimeters. And I know that FN is going to be 6 centimeters. And the question is, what is going to be NR, which is this part right here in blue. So if I redraw this triangle on the side right here, the 90-degree box here, I know this is going to be 10, this is going to be 6. I need to find this x value right there, which represents NR. So if you apply the Pythagorean theorem here, this is going to be x squared plus 6 squared equals to 10 squared. This is going to be x squared plus 36 equals to 100. You bring the 36 over, so you get x squared equals to, sorry, I'm going to calculate it out here. 100 minus 36 is going to be 64. And that means if you do take the square root of each side, that means x has to be, this means that x has to be 8. So this is going to be 8 centimeters. So that right there is going to be 8 centimeters, and this is going to be because of the Pythagoras Pythagoras theorem here. All right, so I believe that this theorem came up in a previous problem as well. And finally, FO. The last question here is not too bad. We know that Fn is going to be 6, so that means that these sides are equal, so this has to be 6 as well. So FO is going to be 6 plus 6, which is going to be 12 centimeters, and that means 6 plus 6 equals to 12 centimeters. Okay, and there we go. I'm sorry that I kind of rushed through some of these problems. I was just trying to get this done in a timely manner here, but here is a better answer key for the problems that were presented in the homework.